Okay, let's talk about biconditionals. A biconditional, you can make one if the conditional and its converse are both true. Then you can make a biconditional. So if the conditional if P then Q is true, and the converse if Q then P are both true, then you can make, this is what's called a biconditional, P if and only if Q. The reason that we consider the conditional and its converse is because the conditional is logically equivalent to the contrapositive and the converse is logically equivalent to the inverse. So if both of them are true, the statement's just always true all the time. So we can write P if and only if Q. And sometimes we shorten if and only if with IFF. It's just faster that way. So if we have the statement, if you eat breakfast, then you will do better at school. That is a true statement. So let's look at the converse. The converse being, if you do better at school, then you ate breakfast. That sounds true enough. I'm not sure if your performance in school is dependent on whether or not you eat breakfast, but we'll pretend that it's true in this case. So since both the conditional and its converse are true, we can write the biconditional. You eat breakfast if and only if you do better at school. And that's all there is to it. And we just take, it's just hypothesis, if and only if, conclusion. Same way with conditionals, it's if hypothesis, then conclusion. The biconditional is hypothesis, if and only if, conclusion. So another one, if two lines are perpendicular, then they form right angles. That is absolutely a true statement. So let's look at the converse. If two lines form right angles, then they are perpendicular. That is also a true statement. So we can make the biconditional. Two lines are perpendicular if and only if they form right angles. That's all there is. One more. If x equals 6, then x squared equals 36. That is a true statement. So let's look at the converse. If x squared equals 36, then x equals 6. That's a false statement. Because if x squared equals 36, x could equal negative 6. So this statement is not always true, so we cannot make a biconditional out of it. The end.